So hello everybody, welcome back to another video. In today's video, we're going to be discussing one of the fundamental concepts of calculus, that is integration. I'm just going to introduce it to you and we're going to solve a few pretty basic sums just for you to get a hang of it. So without any further ado, let's begin. Now, as I said, what integration is, I'm pretty sure you guys would have got a small demo of it in physics, right? So before we get to integration, we have to understand the basic concept of a graph. So in a graph, this is always the x-axis and this is always the y-axis, right? Now, on a graph, how do you represent a certain function? We represent a certain function using a line, right? This is the certain function that we have to represent. Now, in physics, you would have gotten, velocity time graphs, and you would have gotten the slope, which is the displacement, right? So the slope usually represents your function over here. So, for example, you got this slope, which represents the displacement. So to calculate the displacement, you just have to find, the area that the slope kind of, emits. But there's no guarantee that the function that you're going to have to integrate would be a straight line. It could be a twirly little slope, right? And how do you exactly find the area of it? That's where you use the concept of integration. So over here you have this slope over here, and to represent the integral of the slope, what scientists have done is that they have converted these things into really tiny rectangles, right? The distance between all of them being constant, and they have just divided it into really tiny rectangles. So they use the formula and they calculate the area of a single rectangle, and then sum up all the areas. So when you look at integration, it's basically just the sum of all these areas, right? So that's the reason they represent it with this twirly S symbol right here. Now obviously we're not going to physically add things in integration, right? It's just going to be a lot easier than that. We're just going to get to some basic factors related to what integration is. So let's say I have a certain function. Now in calculus we have functions, right? We move on towards functions. Now let's say I have a certain function, let's say f of x, right? Dx is our function. Now if I want to integrate this function, I would have to follow a few rules. Now first of all, when you have to find the integral of, let's say, x, right, the constant x, the variable x. Now x, let's give it a power, let's say x to the power of 3 dx. How would you find the integral of this? The basic concept in integration is that it is the opposite of differentiation. What you guys would have learned in differentiation is just x squared is equal to 2x, right? Basically, x to the power of n is equal to n x n minus 1. This is kind of the formula you guys have to remember for differentiation. But in integration, it is exactly the opposite of this. In integration, we add a power to our already existing power and we divide by the new power, right? That is ultimately what we have to do. So now our case is this. Let's say we have the integral of x cubed dx. Now dx here represents the difference of x, right? What you have to do is you have to just add a power. So x 3 plus 1 divided by 3 plus 1, which is x to the power of 4 divided by 4, right? So now if you get 4x cubed, it would just be 4. It would just be 4, x to the power of 4 divided by 4, which is just x to the power of 4. Now here's where you need to remember one more thing. Whenever you're integrating something, you always have to add a constant of integration. Reason being, there's always a leftover constant after you have gotten your specified integral, right? This constant is always unknown to us, and there's no possible way to find out what this constant original value is unless you differentiate the function, right? So you have to kind of realize that what you're integrating is just the derivative of another function. So it's kind of like a cycle. So we have integration and then we have differentiation. So it's kind of like a cycle. So while you're integrating, if differentiation is your strong spot, then all you have to say is what should be differentiated to get this particular integral. And that is how you solve your integrals, right? So if you have the integral of, let's say anything, let's say you have 5x cubed, right? Dx would be the difference of x. Now this would just be 5x 3 plus 1 divided by 3 plus 1, which is just 5x to the power of 4 divided by 4. So in other words, it's just 5 by 4x to the power of 4 plus c would be your answer. So integration is quite simple, right? These are just some basic rules you need to remember in integration. Now, obviously, there's a concept of limits. As I told you, integrating is kind of like finding the area beneath the slope of a graph. So let's say you want to find the area between this point and this point. That is when you use your concept of limits, right? Limits h is to whatever, infinite. The limit part we'll get to later. But what I'm just saying is when limits exist, that just overcomplicates everything. But at the same time, it makes it more beautiful, right? So you have your integral, which is a clear concept now. So when limits come into rule, we have specified names which I want you to learn. So when you just have the integral, that is called an indefinite integral. But when you have an integral with a certain limit, let's say a, b, right? So this would be called a definite integral, whereas this would be called an indefinite integral. So for now, our funda is to focus on the concept of indefinite integrals, just so you guys can, understand it. We'll go step by step. Integration, as I told you, is the opposite of differentiation. Now, there's a few formulas you need to remember. One, the basic formula. So you have the integral of x to the power of n. It would just be x n plus 1 divided by n plus 1 plus c. This is your answer. Now, what if you want to say, what is the integral of 1 by x dx? Tell me the answer quickly. In fact, it is not possible. Why isn't it possible? Because this rule applies to every single power except for minus 1. Why? Because see, it is x raised to n plus 1 divided by n plus 1. So when your n is minus 1, right? When your n is minus 1, this becomes x to the power of 0 divided by 0, right? And you cannot divide by 0. This would be not defined. So for that reason, this would not apply. So ultimately, if you look at this itself, it is just x inverse, right? So it's the integral of x inverse dx. So if you ever get this, you have to remember the identity. This is just log x to the base e plus c, right? This is something you guys need to remember. So you can never have minus 1 as your power, and you can never integrate it, kind of increase the power, right? That isn't really possible. So these are your cases. Now, one more thing you guys need to remember is when you get an integral, what do you really have to do? Let's say I have the integral of any random function, f(x), it can be plus or minus e x, right, dx. Let's just say this. Now, since this is plus or minus, in this case, this integral would apply for both this function as well as this function. So this would just be integral of fx dx plus or minus the integral of e x dx, right? It would just be the integral of this. So you have to remember that this only works in the case of addition and subtraction. Multiplication, division, this identity will not work. Got it? This identity will not work in the case of multiplication, division. Only addition, subtraction, this will work. So if you have some part, right, if you can remove a constant out, have this part. So if you always have just the integral of function number 1, and then you have plus or minus the function second function, then you kind of have to, integrate the first function plus or minus the integral of the second function. That would be applicable in that case. Now, there's one more thing you guys need to remember. Let's say you have a constant. Now you have an integral here and you have a constant. Let it be any random constant. It would be 5, right? 5 dx. How would you exactly solve this? Now, whenever you have an integral and you have 5 and then you have some function after that. Let's say you have 5 and then you have some other function after that. The first step is that you have to remove the constant out. So it would just be 5 integral fx, because you just want to integrate the function, right? Whenever there's an additional constant there, you do not integrate it. So what if you just have the integral of a constant? What if you just have integral of 5 dx? In that case, first step, as I told you, just remove 5 out. Remove the constant because you just want to integrate, the function. So you remove 5 out. And now all we are left with is 1, right? 1, and then we have dx. Now the integral of 1 to everybody knows it's x, right? So it's just 5x plus c. This was an area where people mugged it up. Why is the integral of any constant just equal to kx plus c? It is for this reason, right? Because when you take the constant out, ultimately the leftover part is integrated, which is just 1, and that becomes x, right? So that is what you guys need to remember about integration. And one more thing you guys need to remember is, I also told you that it is not possible to have, a negative power, right? Like you can never have x inverse. Also, if you have, let's say, the integral of 12 dy, it's just 12y plus c, right? Because we're not changing anything. If it's dx, dy, the value doesn't really change, right? So can we start solving some sums? Before we get to the sums, I want to introduce you to some trigonometry. And yes, beta, there's trigonometry in this as well. And it's very easy trigonometry. So you just have to remember a few anti-derivatives, a few, relations, which we'll get to right now. First, we have, let's say, the integral of sine x dx. The integral of sine x dx is just negative cos x plus c. Negative cos x plus c, because when you differentiate this, you should get this ultimately. Next, you come to integral cos x. Now, what if you have cos x dx? In that case, it is positive sine x plus c is your integral, right? Next, we come to, let's say, the integral of secant square dx. It is just equal to tan x plus c. Tangent x plus c would be our integral. Very good. One last one. We have cosecant square dx, which is just negative cotangent x plus c would be your integral in this case, right? So these are pretty easy to remember. And you also have the integral of tan x dx, which is just equal to secant x plus c. Pretty easy. So these are 5 relations you have to remember, right, in order to solve your trigonometry sums. Whenever you see trig in integration, you have to remember these basic identities. There's going to be a lot more. This is not even a 1% of what integration truly is. I'm just giving you a basic, introduction to it. There's a lot more that even I have to cover. So yeah, that's pretty much it for now. So here I have some questions for you. Let us try solving these questions together and let's see how you guys are able to do it. So first we have the integral of x cubed minus 6x squared plus x plus 1, right? dx. So it's just direct application of the formula x to the power of n plus 1 divided by n plus 1. So here you just say x, add a power, divide by the new power. Pretty good. 6x squared, add a power, divide by the new power, plus x, you just add a power, divide by the new power. So x squared by 2 plus the integral of 1 is just x, right? Integral of 1 is just x. So now what do we have to do? We just leave it as it is. So x to the power of 4 by 4. Now here 3 goes with 6 twice and that's pretty much it. So yeah. So 2x cubed plus x squared plus x plus c would be your answer. So this is ultimately the answer to this integral, right? You just use some basic formulas. Next, we come to the integral of root 3x dx. Just again, use your regular power rule, right? What you need to do is you can rewrite it as the integral of x to the power of 1 by 3, right? Dx. You're not changing anything. You're just rewriting it as a power. Now, what you can do is you can, start to integrate it. So it is just x to the power of 1 by 3 plus 1 divided by 1 by 3 plus 1, because it's adding a power dividing by the new power. Now in this case, 1 by 1, we have to find the LCM. So we can just rewrite this as 3 divided by 3. So 4 by 3, right? This would also be 4 by 3, 3 by 3. So we have x to the power of 4 by 3 divided by 4 by 3. Okay? Yeah. Now if I want to get rid of this 4 by 3 in the denominator, I can just multiply this by 3 by 4. But since I'm multiplying the denominator, I also have to change something in the numerator. So multiply this also by 3 by 4, right? So it is just 3 by 4 x to the power of 4 by 3. And this just cancels off to 1. Don't ever forget the constant of integration. It's incredibly important. 4x cubed plus cos x dx. Now, just as I told you, you have nothing but the plus sign over here. If you see very clearly, you have the plus sign over here. So in this case, all you have to do is just take the integral of both sides, right? So it's just the integral of 4x squared dx plus we have the integral of cos x dx, right? Nothing, we're not changing anything. Now 4x cubed, the integral of 4x cubed, we can remove the constant out. Left what? X cubed dx, right? Now we have to integrate this, so it's just 4 to the power of, 4x to the power of 4 divided by 4. 4 cancels off. It's just x divided by x to the power of, just x to the power of 4, right? Okay, splendid. Now we come to the other side, which is cos x plus cos x dx. There's going to be a plus c here, right? There's going to be a plus c here. Now the integral of cos x is just it's just sin x, right? So the integral of cos x is just going to be sin x. So ultimately, this entire thing is just x to the power of 4 plus sin x. We have x to the power of 4 plus sin x plus c. This also is a plus c. Now there's a plus c over here. There's a plus c over here. There's two plus c's. Now this would be c1. This would be constant, right? So there's two plus c's. Why am I not writing 2c here? Reason being, we don't really take this as a variable. We take this as a constant. So this constant doesn't have a particular value. We are just writing it to acknowledge the fact that we know that that constant exists. So this is your constant 1. This is your constant 2. When these two constants, act together, it forms a third constant. This is C3. But we are not really putting or numbering it because, there's no need to, in fact, do that because we know that that's just a constant and it has no value here, right? We don't know its value. It has value. Integral of 4 minus 5 sin x upon cos square x. Now we can just rewrite this integral of, now 4 divided by cos square x, just split it into two parts. So what we can do is it's just 4 secant, right? 4 secant square x minus. Now this cos square x, though, we can break into two parts. Cos x multiplied by cos x, right? Because why? Because we just have sin x on top of it. So sin x divided by cos x together will form what? Tan x, right? So there'll be an additional cos x down. So when that comes on top, it'll become secant x. So minus sin x upon cos x, we can write 5 tan x and secant x, isn't it? That's it, dx. So beta, right? Now though it has become very simple. Now all we need to do is just integrate it. 4 secant square x integral is tan x. So 4 tan x minus 5 secant x. So secant x plus c would be our answer. This is just the basic integral, right? That's all you need to remember. Okay, now in this case, we have the integral of dx on top and then sine square x, cos square x in the denominator. Now remember, when you have a dx over here, it is equivalent to 1, right? So we can just say it is sine square x plus cos square x. So we can just rewrite it as, we have to rewrite it though as the integral of sine square x plus cos square x upon sine square x cos square x dx, which is basically just integral of 1 upon sine square x cos square x dx, just becomes what? The integral of, ultimately this goes on top, so it is cosecant square x secant square x. Now just find the integral of both of them, dx, just find the integral of both of them. Negative cot square x, right? So it's just negative cot square x, and then secant square x, though, is just tan square x. So it's tan square x plus c. Your final answer, though, in this case, since it's an integral, you're separating it with a plus sign. So this is negative cot square x plus tan square x plus c. So you can just say tan square x minus cot square x plus c is your final answer. Okay, now let's get to a slightly more tricky integral. This one even comes in examinations. So what we can do is we can just rewrite this as the integral of, now 1 upon 1 plus sin x. We can kind of rationalize it. It doesn't have to be irrational. We can just rationalize it. 1 plus sin x. We can multiply it by 1 minus sin x upon 1 minus sin x, right? So then we kind of have formed an identity over here, dx. So we just have the integral of 1 minus sine x in the numerator divided by now 1 plus sine x. 1 minus sine x is just the a plus b, a minus b identity. So we have 1 minus sine square x, right? Sine square x, because 1 square is just 1. Now the next thing you need to remember is cos square x plus sine square x is equal to 1, equal to, it just becomes cos square x. So from that we can conclude that the next step is just the integral of 1 minus sine x, write it as it is, 1 minus sine x divided by cos square x dx it has become. Now what we can do next is we can kind of, you know, open up the thing. So it just becomes the integral of 1 upon cos square x dx. Next we have the integral of sine x upon cos square x dx. Because it's addition, sorry, it's subtraction in this case, so we kind of, you know, can split it up. Integral of 1 upon cos square x dx, we can just write it as secant square x dx, integral of secant square x dx, minus we have the integral of now sine x upon cos square x, sine x into cos x, sine x by cos x is tan x, into the cos x goes on top, so it becomes secant x. So it's just the integral of tan x secant x dx, right? And now all you need to do is kind of evaluate it, open up this integral. So this just becomes the integral of now secant square x dx. Just what's the integral of secant square x? It is tan x, right? So it's just tan x. So we can just write this as tan x minus the integral of tan x, though you know, is secant x, and that goes away, so it's just plus c. So this would ultimately be your answer. So tan x minus secant x plus c, this is your answer. As you can see, this is an indefinite integral, so there's no limits here. So this is your final answer, right? This is just the basics of integration. I'll try to get into more of trigonometry, more of the constant power rule, and I'll try to introduce you to a few more, you know, and also try to deal with differentiation for you guys, try to simplify it a little more. This is very easy, right? I don't think any of you would have found this difficult. It's very easy. It's an easy concept. So thanks a lot for watching, and I'll see you guys in the next video.